Hello, I am Dr. Sigar Kanti. In this video, we discuss finding analytic function if the real part or the imaginary part is given. See here, the method is let f of z be required analytic function. Analytic function. Now, f of z is equal to u plus I into v. And we know that f dash of z is equal to dou u by dou x plus I into dou v by dou x. Now here, if u is given, then I can find out dou u by dou x and dou u by dou y. Okay, so we can find these two. But here, f dash of z is dou u by dou x plus I into dou v by dou x. As u is given, I can find out dou u by dou x, but not this dou v by dou x. But we have CR equations are Cauchy-Riemann's equations are dou u by dou x is equal to dou v by dou y and dou u by dou y is equal to minus dou v by dou x. Okay, so therefore I can write f dash of z is equal to dou u by dou x plus I into dou v by dou x can be written as minus dou u by dou y minus dou u by dou y into I. Okay, so here we can find out dou u by dou x, dou u by dou y. Then find these dou u by dou x and dou u by dou y at x equal to z and y equal to 0. X equal to z and y equal to 0. Then this becomes a function of z. This becomes a function of z. Then integrating this equation with respect to z, we find f of z. This is the method, and this method is known as Milne-Thomson method. Okay, and suppose v is given. So here, if v is given, then I have f dash of z is dou u by dou x plus I into dou v by dou x. If v is given, then we can find out this dou u by dou x, but not this dou u by dou x is not possible. So for that again we go for the CR equations. By CR equations we have dou u by dou x can be written as dou v by dou y. So therefore here we can write f dash of z is equal to dou u by dou x can be written as dou v by dou y plus I into dou v by dou x, and again find dou v by dou x and dou v by dou y at x equal to z and y equal to 0. That is, put x equal to z and y equal to 0 here in this dou v by dou x, dou v by dou y. Then this becomes again a function of z. So integrating this equation, we get f of z. So this is the method. This method is known as Milne-Thomson method. Okay, I'll go to an example. Find the analytic function. Find the analytic function. given that given that the real part is the real part is u equal to x cube minus 3xy square. Okay, this is our u is given. Then first we find dou u by dou x is equal to 3x square minus 3y square. This is our dou u by dou x. And dou u by dou y is equal to differentiating partially with respect to y, derivative of this is equal to 0. Differentiation of this partially with respect to y, x is a constant quantity, 3 is a constant quantity, y square derivative is 2y, this becomes minus 6xy. This is equal to minus 6xy. Okay, and here we have f dash of z is equal to, and here we can find out uh, at x equal to z and y equal to 0, we get dou u by dou x is equal to 3z square and dou u by dou y is equal to 0. Okay, so because here we have y is there, if I put y equal to 0, the whole term becomes 0. And we have f dash of z is equal to dou u by dou x plus I into dou v by dou x. This can be written as dou u by dou x. Dou v by dou x can be written as minus I into dou u by dou y. Substituting here, this we get here f dash of z is equal to, what is dou u by dou x? This is 3z square. Okay, and dou u by dou y is equal to 0. That is, so this term becomes, whole term becomes 0. I am getting f dash z is equal to 3z square. Just integrate this. Integrating, we get f of z is equal to 3z square. Integration is 3 into z cube by 3 plus constant quantity c. Okay, so that is here. This is equal to f of z is equal to 3 gets cancelled. Z cube plus c is the required is the required analytic function. This is the required analytic function. Okay, I'll go to another example. Find the analytic function. Find the analytic function whose real part is u equal to e power of x into x cos y minus y sin y. Okay, u is given. Now the same method, first we find out dou u by dou x is equal to, see here, this is a function of x, this is also a function of x. Okay, we have to use the product rule. First function e power of x into, within this bracket, we are differentiating with respect to x. The first term derivative cos y is a constant quantity, x derivative is equal to 1 minus, these two are constant quantities, therefore its derivative is 0, plus second function is x cos y minus y sin y into derivative first, e raised to x derivative e raised to x, and at x equal to z and y equal to 0, we are getting dou u by dou x is equal to Cos 0 is 1. E power of z into 1 is e power of z. And here cos 0 is 1. This is our z plus z into. See here y into sin y. We are substituting y equal to 0. Therefore, this whole term becomes 0. That is, this is z into 1 into e raised to z. That is z into 1 into e power of z. This is our w by dou x. What is w by dou y? Differentiating partially with respect to y, e power of x is a constant quantity. We keep this as it is. Within this bracket, we have to differentiate this with respect to y. So for the first term, x is a constant quantity as it is. Cos y derivative is minus sin y. Minus. See here, y into sin y. Both are functions of y. We have to use the product rule. First function y, sin y derivative is cos y plus. Second function is sin y into derivative of y is 1. Okay. Now this is at x equal to z and y equal to 0. If I put y equal to 0, see sin y, this becomes 0. So this term becomes 0. Here y is there, this term becomes 0. Sin y is there, sin 0 is 0. That is whole bracketed quantity is 0. 0 into anything is 0. So that is here dou u by dou y is equal to 0. Now f dash of z is equal to dou u by dou x plus I into dou v by dou x. This is equal to dou u by dou x. See here, dou v by dou x can be written as minus dou u by dou y. That's minus I into dou u by dou y. That is f dash of z is equal to dou u by dou x. Dou u by dou x is e raised to z plus z into e raised to z. E raised to z plus z into e raised to z. And dou u by dou y equal to 0. Therefore, this term becomes 0. Just integrating this. Integrating, we get f of z is equal to e raised to z integration is e raised to z itself plus. So integrating this one, so we have to use the integration by parts, taking z as the first function, e raised to z as the second function, and we can use the general rule here. First function z, integration of second is e raised to z, next minus sign, derivative of z is 1 into integration of the second e power of z integration e power of z. Then we have to write plus and we have to write the derivative of this 1. That becomes 0 and the next term all becomes zeros. That is, this is the last term plus a constant quantity c. Now here this e raised to z minus e raised to z gets cancelled. Therefore, f of z is equal to z into e raised to z plus c is the required analytic function. This is the required analytic function. Next, I will go to another example. One more example. Find the analytic function find the analytic function whose imaginary parties v is equal to x into sin x into sin hy minus y into cos x cos hy. Okay, so v is given. The method is same. First we find the derivatives. W by Wx is equal to. See, sin hy is a constant quantity. I will keep the sin hy as it is into. We have to use the product rule here. First function is x into sin x derivative is cos x plus second function is sin x into derivative of x is 1 minus here y into cos hy is a constant quantity minus y into cos hy constant quantity. Cos x derivative is minus sin x. Okay. Now this w by wx at x equal to z and y equal to 0. This is equal to. If I put y equal to 0, what is sine of h0? Sine of h0 is equal to 0 itself. So 0 into this term becomes 0 minus we are taking y equal to 0. 0 into anything is equal to 0. So that is this whole quantity is equal to 0. W by x equal to 0. What about w by y? If I differentiate this with respect to y, x sin x is a constant quantity. X into sin x is a constant quantity. Sin hy derivative is cos hy minus cos x is a constant quantity. Cos x is a constant quantity. Y into cos hy derivative. We have to use the product rule. First function y into cos hy derivative is minus sin hy plus cos hy into derivative of y is 1. Okay. Now w by y at x equal to z and y equal to 0 is equal to. We have to put x equal to z and y equal to 0. If I put y equal to 0, cos h0 is 1. Okay. This is 1 and this is z. This is sin z. That is z into sin z. Z into sin z minus. We are taking x equal to z. This becomes cos z into here. This becomes cos z. Okay. Minus cos z into. So if I put y equal to 0, this term becomes 0. Okay. Plus cos hy, this is equal to cos h0 is equal to 1. So that is 1. Now f dash of z is equal to w by wx plus I into w by wx. So here w by wx can be written as w by y by CR equations. This is our w by y plus I into w by x. So that is f dash of z is equal to what is w by y? We have this z into sin z, z into sin z minus cos z, okay, plus I into w by x. We have w by x is equal to 0. So this term becomes 0. Now just integrating this, integrating, we get f of z is equal to. So here we have to use the integration by parts using general rule of integration. That is first function z into sin z integration is minus cos z, next minus sin. Derivative of z is 1 into integration of minus cos z is minus cos z integration is sin z minus. Now this is the last term because next I have to write the derivative of 1, that becomes 0. All the terms after this become 0. Minus cos z. Cos z integration is sin z plus a constant quantity c. So this is equal to minus z into cos z plus sin z minus sin z plus c plus sin z minus sin z gets cancelled. Then this is equal to f of z is equal to minus z into cos z. This is the required analytic function. Minus z cos z plus c. So this is how we can find out analytic function if the real part is given or the imaginary part is given. Okay, thank you. I'll stop here.